So this is the second half of the 4.6 notes, and it's going to be very similar to what we did with conjugates with irrational numbers before in section 4.5. So the complex conjugate theorem says if a polynomial function has real coefficients, I think last chapter it said if it has rational coefficients. It says it has real coefficients and a plus bi is an imaginary zero of f, then so is its conjugate a minus bi. So with that information, we're going to write equation, or we're going to use the zeros to find, or use the roots to find the equation. Write a polynomial of least degree that has rational coefficients, or real coefficients, a leading coefficient of 1, and zeros of 2 plus 3i. It really should say solutions of 2 and 3 plus i, because 3 plus i is not a zero. I know this is probably from the book, and it's probably, I just don't think it's right. It should be the roots or solutions, but 3 plus I does not show up on the graph, so it's not a zero. So automatically I know that 3 minus I is also part of one of the solutions. So if 2 is a solution, then x minus 2 is a factor. If 3 plus I is a solution, then x minus 3 plus I is a factor. And x minus 3 minus I is a factor. So this should look very similar to what we did before. All right, so I'm going to get rid of the parentheses. I'm going to say x minus 3 minus I, because it's the opposite of that thing. And the opposite of 3 minus I would be like that. Now you could do that in a big table again. You might want to pause the video and try this out on your own. Make sure that you can get the right answer. X minus 3i and x minus 3 plus I. So x minus 3 plus I. So pause the video, see what you get. All right, well, if you tried it, you'll get x squared minus 3x minus 3x, 9, just like before. And these guys are going to add up to 0, because you're going to have negative ix and positive ix and positive 3i and negative 3i. So I'm not even going to write them. I times negative I, if you remember how that works, I squared is negative 1, so negative I squared is positive 1. So that gives me x minus 2 times x squared minus 6x plus 10. Okay, multiply those together, take a pause, and write the answer. Okay, I'm going to do it out. You can listen to my method, but it shouldn't take that long. So I'm going to have an x squared and a negative 20. And then let's see, I have a negative 6 and a negative 2 makes negative 8x squared. And I have positive 10 and positive 12, which makes positive 22x. And you can check that out on Desmos. You should get positive 2 as one of the zeros. And the other ones you won't see because they're invisible, because they're imaginary. All right, let's try another. Write a polynomial function. Oh, this has got square roots and i's. How exciting. The polynomial function of at least degree that has rational coefficient and leading coefficient of 1, and the given roots of 3 and 1 plus I radical 5. Well, that's kind of I need to get the conjugate of that thing. So take a second and write the factors first, and then we'll check those. Pause the video. All right, so the factors are x minus 3, and I'm going to get rid of the parentheses, x minus 1 minus I radical 5, and x minus 1 plus I radical 5. All right, that's what you should have. You should have parentheses first if you did it the right way. X minus 1 plus I radical 5 and x minus 1 parentheses 1 minus I radical 5. All right, I would suggest multiplying these guys together first because it'll be a whole lot easier. So make your big box or however you're going to do it and write that out. Pause the video if you haven't done so. All right, I get x squared minus 2x, and then what I'll have? Positive 1, and let's see, I'm going to have negative I squared, which is positive 1, times 5, so that's plus 5, so 1 plus 5 is 6, right? That's right. Negative I squared is negative 1, that's positive 1, and radical 5, it's times radical 5, so radical 5 times radical 5 is 5, plus the 1 that was there from squaring the x plus 1. All right, so that's what I get. Now multiply those two together. All right, let's see what you get. X to the third and negative 18 for the first and last. I always find those easier to do if I'm not using a box or something. And then I get negative 2 and negative 3 makes negative 5x squared. And positive 6 and positive 6 makes positive 12x. There it is. I don't need those parentheses. I don't know why I have them. All right. So there's my answer. That's a polynomial of least degree that has these solutions. All right. One more. Go ahead and do this one on your own. Pause the video and try the whole thing. I hope that you started by putting the conjugates out there, because these have irrational numbers and square roots and imaginaries and everything. So if I can see what it looks like, it's supposed to be 1 plus 3i and 1 minus 3i. Since it's a square root of 2, you have x minus 2, or the negative square root of 2. So here's what I have. Factors. X plus and minus the square root of 2. And then I have x minus, I'll put them in parentheses. Now, root of 1, 2, do more steps than I need to. Minus 1 plus 3i and x minus 1 minus 3i, because it's the opposite of 1 minus 3i and the opposite of 1 plus 3i. All right. You can pause now if you didn't get the right answer so far. You can pause and fix it and keep on going from here. All right, so this one is x squared minus 2 because the middle terms drop out. Over here, the middle terms drop out of this one too. I don't know if you guys realize what's happening here, but if you look at it as a difference of squares, it's this plus 3i and this minus 3i. So it's going to be x minus 1 quantity squared minus 9i squared. That's how I'm able to do them in my head, because I know it's a difference of square, just like x minus 2, x minus the square root of 2, x plus the square root of 2. Middle term is going to drop out. So these terms and these terms are going to add up to 0. If you do it in a box, those are the 4 boxes. But otherwise, we're going to have x squared minus 2x plus 1, and negative 1 times negative 1. That would be the x minus 1 quantity squared. And then we're going to have minus 9i squared, which is plus 9. So that's plus 10. Not, it's going to be 1 plus 9, which is 10. All right. One more step. I'm going to multiply out this whole mess. Let's see. X to the fourth, negative 20. Let's see where the x to the thirds are. I have an x to the third over here, and that's the only one. Negative 2x to the third. Let's see how many x squareds I have. I have an x squared. The outsides, let's see, that's 10. And we have a negative 2. 10 and negative 2 makes 8. X squared. How many x's do we have? Just this one. Plus 4x. Okay, I hope I got them all. That should be all of them. All right. I think that's enough of that. So using those, using the roots, we can find the original equation. And notice that my equation has, there are no coefficients that are irrational. There's no coefficients that are imaginary, although I guess I could have irrational coefficients, because they said they could all be real. That's it.